Hello guys, welcome to Unit 11, Lesson 1. Our topic today is Introduction to Related Rates. So what are related rates? They're basically applying derivatives to real-life applications. So in the warm-up, we are asking to do is write each of the following statements mathematically as a rate of change with respect to time. So originally, when we were taking the derivative, it was change in y over change in x, which is dy over dx. Now we are going to take the derivative of, which is the slope of any variable with respect to time. So that's what we want to do. Okay, so we will be using our implicit differentiation and stuff like that. So basically we're going to be writing, since we are differentiating with respect to time, so whatever it could be, our variable could be anything. So it might not be y all the time, so it'll be the derivative of the variable over derivative with respect to time. So part A says Max is growing at the rate of 2 inches per year. So Max, that would be dm over with respect to time is dt, right? So he's growing at 2 inches per year. He's growing, so it's going to be positive, and if it's decreasing, it's going to be negative, and so on. My car is losing its resale value at $10 per day. So my car, so my dc over dt would be what? It would be negative because it's losing negative $10 per day. The radius of a circle gets larger by 4 feet each hour. So my radius with respect to time, or how's my radius changing with respect to time, is 4 feet each hour per hour. And the outside temperature is dropping at 5 degrees Fahrenheit per minute. So I'm going to use capital T for temperature and lowercase t is for time, and it would be dropping, so it's going to be negative 5 degrees Fahrenheit per minute. Okay, so what are related rates? So related rates, I already filled in the blanks, so you can copy them. Calculus is the study of change, right? That's our slope, rate of change. Related rate problems are an important application of calculus that involve finding the rate at which some variable changes over time. That's why we will be differentiating with respect to time. What is happening to a given variable with respect to time? So we will need to take a formula that relates static variables and use differentiation methods to create one that relates their rates of change. The static variable is something that doesn't change. So let's get started with the example. It says assume the radius r of a sphere is differentiable function of t, and let v be the volume of the sphere. Find an equation that relates dv over dt and dr over dt. So it's giving us the volume. So how do I find dv over dt? So I'm going to take derivative of both sides. So what do I get? dv over dt. I'm taking derivative again with respect to time. So remember, 4 over 3 pi is just a number. So we're going to use a power rule. So it'll be 4 over 3 pi. Oops. It's going to be, actually, I'm going to show you the whole thing. It's actually going to be 4 over 3 pi times 3. The 3's cancel out, but I'm just going to write it 3r square. And then dr dt. Don't forget your dr dt. So this is how you find your derivative. I'm going to just simplify that. 3's actually cancel out, and I have pi r squared dr dt. And this is dv dt. Okay, so basically it's the rate of change of volume of the sphere with respect to time. That's what this equation represents. So just take a minute and copy that down into your notes. Steps for related rate problems. So you always want to draw a picture, sketch it. You don't have to, doesn't have to be perfect. Then, because since they're word problems, you want to make a list of your knowns, your given information, and knowns or given information, yes. Then write down what you're looking for, always, because that helps you set up your equation or look for things. So writing it out on the side of the paper, it's a great idea. Write an equation that relates the variable plug in the constants so that you can solve for that variable. Differentiate with both sides with respect to time, right? And then evaluate. So let's get started with the question, and then these things will make more sense. So here it's example 1. It's saying the length of a rectangle. First of all, I'm going to sketch a rectangle. We just talked about it, right? We all know what a rectangle looks like. This is your width and these are your length. The length of a rectangle is decreasing by 2 inches per second. So the length, so let's say my length is L. So it's dl over dt with respect to time. It's decreasing, so it's going to be negative 2 inches per second. And the width is increasing by 3 inches per second. So my dw over dt is 3 inches per second, and it's positive because it's increasing. When the length is 10, so when your length is 10 and your width is 6, how fast is the perimeter and the area changing? So we are looking for part A. We're looking for a perimeter. So what is the perimeter of, we're basically looking for, it's changing dp over dt. That's my question mark. So what is the formula for perimeter? It is, the perimeter means the outside length, right? We're just adding up. So 2L plus 2W. So 2L plus 2W. Now what do? We take the derivative on both sides with respect to what? Time. So your implicit differentiation would come in handy. So it'll be dp over dt equals, think of L as your x. So what is the derivative of x? Just 2x, just 2, right? But since we are differentiating with respect to time, we're going to write dl over dt plus 2d, similarly dw over dt. Okay? So now we are going to do what? Once we've taken the derivative, substitute in all the values you know. So dp over dt equals 2 times, what's my dl dt? Negative 2 plus 2 times 3, which is what? Negative 4 plus 6, which is 2. And this is perimeter, so it's going to be inches per second. So that's basically it. Write your units down. So at this rate, it is, the perimeter is increasing at 2 inches per second. Okay, now part B. It is asking me to find the area changing. So dA over dt, right? So what is the formula for area of a rectangle? It is length times width. Now this is your product rule, which would be what? I'm just going to write it here. Oops. A times B is A prime B plus AB prime, right? So take the derivative on both sides. dA dt equals the derivative of the first variable, which is just 1, times dl dt times w plus the derivative of the second variable, first times derivative of second, which is 1, times w over dw over dt. Does that make sense? Right? All we're doing is taking the derivative and we're just considering them as just any variable. And we are doing implicit differentiation because we are differentiating with respect to time. Okay, or now what do? We already took the derivative. Now you want to substitute in the values because I want to find my rate of change of how fast is the area changing. So I'm going to do dl dt is negative 2 times my width is 6 plus my length is 10 times 3. So negative 2 times 6 is negative 12 plus 30, which is 18. Area is squared, so it's going to be 18 inches square per second. So that's how your area is. Example 2. It says a pebble is dropped into a calm pond using ripples in the form of concentric circles. So basically, If you've drawn a pebble in a pond, it forms circles like this. Concentric circles are one outside the other, right? With the center right there. The radius r of the outer ripple is increasing at a constant rate of 2 feet per second. So that is my what? dr dt. That's how it's changing. That's the rate of change for the radius. It's increasing, so it's going to be positive. Remember, in this lesson, positives and negatives do mean something, or this unit, I would say, for that matter. When the circumference of the ripple is 8 pi feet, so your circumference is 8 pi, what is the rate of the total area of the disturbed water increasing? So they want us to find dA over dt. That's what they're asking us. So it's a circle, so area of a circle is what? Pi r squared. The formula for area of a circle is pi r squared, right? So I'm going to differentiate. I'm going to get my differential equation by differentiating both sides with respect to t. So it's going to be dA dt. Think about pi is just a number, right? So what's the derivative of r squared? It is going to be 2 pi r. Since we are differentiating, we took the derivative of r, we are going to be writing dr dt next to it. So now I want to find dA over dt, right? 2 pi is just a number. R I don't know, but I do know my dr dt. How can I find r? I was given the circumference was 8 pi. If you know your formula for circumference, there are two formulas. Either you can say pi d equals 8 pi or 2 pi r equals 8 pi. If I want to solve for r, so I'm going to divide by 2 pi. On both sides, I get what? R is equal to 4. So I'm going to take this r and substitute in there. You can't have two things, right, to solve for. So dA over dt is equal to 2 pi times 4 times, and my dr dt is 2. So just multiply them. 2 times 4 is 8. 8 times 2 is 16. So your dA dt is 16 pi feet square. I know it's not asking us the units, but it's a good practice to write the in units per second, right? It's positive means what's so the area of the circle is increasing. Okay, I'm going to do one more question, and then I'm going to leave you with the remaining lesson to finish up. So it says the side of a square is increasing at a rate of 3.5 feet per minute. So it's talking about the side of a square. So let's call that S. So my rate of change is what? ds over dt is 3.5 feet per minute. At the instant of the side has a length of 2. So I'm going to sketch a square also. So my side length is 2. So my S, we used S for the side length, is 2 feet. Now it's asking us for how fast, again, that's the rate of change, is the area of the square changing. So I want to find the area, how fast is the area changing with respect to time, right? Remember, in a square, all sides are equal. We do know that. So now what is the area of a square? Isn't that, let's do A. Area is S square. You can say L, then you should have written L in place of S. It doesn't matter, as long as you're consistent with your letters. So I am going to take my derivative on both sides. So it's going to be dA dt, right? Because the derivative of A is just 1, but I'm differentiating with respect to t. That's why it's d over dt, if anyone's confused with that idea. And then think about it. What is the derivative of x squared? It's 2x. So it's going to be same, but I'm going to write ds dt because we are differentiating with respect to time. Okay? So now, do I know my s? Yes, I do. Do I know my ds over dt? Yes, I do. So all I need to do is substitute in. So 2 times 2 times 3.5, which is what? 2 times 2 is 4. 4 times 3.5 is 14. So dA dt is 14. Again, this is area, so it's squared. So it's feet squared per minute. If you're not sure about your units, don't write them if it's not asking, because if you write wrong units and if they didn't even ask, you do get points taken off. So be very careful. But I want you to, at least in your lessons, practice them so you get more and more comfortable with those. So now it's saying part B, how fast is the perimeter of the square changing? The perimeter formula for square is what? 4s, right? Because all sides are same. So I want to find dp dt. So I'm going to take the derivative on both sides, which would be just 4 times ds dt. So my dp dt would be 4 times 3.5, which also happens to be 14. But remember, it's first of all, it's positive, means the perimeter is increasing, and the perimeter represents a singular unit, right? So it's going to be just feet per, and its rate of change, so feet per minute. Okay, so I want you to finish up the remaining lesson, and if you have any questions, please reach out.